The universe does not announce its most profound changes with a roar. It speaks in the language of the infinitesimal, a stutter in a shadow, a millisecond lost to the void, a silent departure from the mathematics of the past. For 4.5 billion years, the Earth has performed a seamless, rhythmic ballet, bound to the sun by the invisible tension of the cosmic anchor. We have lived our entire history within the comforting precision of this celestial clockwork, trusting that the duration of a heartbeat and the rotation of the world were constants written into the very fabric of reality. But lately, the rhythm is off. Suspended in the velvet throat of the vacuum, our lonely sapphire marble has begun to experience a shiver, a fundamental deviation in its most ancient metrics. The reliable friction of the moon, which has acted as a steady brake on our planet's spin for eons, is no longer the sole master of our time. Against every known law of planetary inertia, the Earth is accelerating. The days are shortening, shrinking beneath the gaze of our most precise atomic clocks, as if the world is bracing for an impact that has not yet arrived. Simultaneously, the deep, molten heart of the planet is restless. The magnetic north, once a slow and predictable wanderer, is now sprinting across the Arctic, fleeing toward Siberia with an urgency that defies explanation. It is as if the Earth's internal compass is being pulled by a ghost, a thickening of the very space through which we travel, an unknown influence lurking in the dark sectors of the galaxy. When the ship begins to veer off an uncharted course, what becomes of the passengers who never knew they were moving? This is the story of an anomaly that should not exist, a silent, planetary rebellion that threatens to dismantle our understanding of geophysics and rewrite the future of the world. To understand the magnitude of what is happening beneath the feet of every living soul, one must first understand the guardians of our seconds. Deep within the climate-controlled vaults of the International Earth Rotation and Reference System Service, the IERS, there exists a standard of reality that transcends the human senses. Here, the passage of existence is not measured by the rising sun or the shifting tides, but by the relentless vibration of cesium atoms. These atomic clocks are the high priests of our era, instruments of such terrifying, crystalline precision that they would not lose a single second even if they had begun their countdown at the moment of the Big Bang some 13.8 billion years ago. For decades, these machines confirmed a fundamental truth of geophysics. The Earth was a slowing world. Like a spinning top losing its vigor on a cosmic floor, our planet was gradually yielding to the invisible hand of the moon. This lunar braking was a constant, a gentle drag of the tides that added a few milliseconds to the day every century. The math was settled. The future was predictable. Until the late 2010s arrived, and the clocks began to whisper a different story. In 2020, a year already marked by terrestrial upheaval, the atomic guardians noticed a glitch in the celestial clockwork. The Earth was no longer slowing down. It was accelerating. On July 19th of that year, the planet completed its rotation 1.47 milliseconds faster than the standard 24 hours, the shortest day ever recorded since the invention of the atomic clock. This was not a fluke or a momentary shudder. It was the beginning of a trend that defied every established model of planetary behavior. Throughout that year, the Earth broke its own speed record 28 times. The observers at the IERS found themselves in a state of quiet, academic shock. To change the rotation of a mass as gargantuan as the Earth, 6 sextillion tons of iron, rock, and water, requires a force of incomprehensible magnitude. It was as if a phantom hand had reached out from the darkness of the solar system and spun the globe just a fraction faster. The leap second, a tool traditionally used to slow our clocks down to match a sluggish Earth, suddenly faced an existential crisis. For the first time in history, scientists began to discuss the negative leap second, the need to subtract time from the human record to keep pace with a world that was suddenly, inexplicably, in a hurry. But as the chronometers in Paris and Colorado were registering this temporal shift, another anomaly was being tracked in the high latitudes of the north. If the IERS are the watchers of time, the British Geological Survey and the National Oceanic and Atmospheric Administration are the watchers of the Earth's soul, its magnetic field. Since its discovery in 1831, the magnetic North Pole has always been a wanderer. It is born of the geodynamo, the swirling, turbulent sea of molten iron 3,000 kilometers beneath our feet. For over a century, this point on the map drifted lazily across the Canadian Arctic, moving at a predictable pace of perhaps 10 to 15 kilometers per year. It was a slow, geological stroll. Navigators and scientists adjusted their maps with a sense of routine, confident in the stability of the Earth's internal engine. However, as the 20th century bled into the 21st, the stroll became a walk, and the walk became a sprint. By the mid-2010s, the magnetic North Pole was no longer drifting. It was racing toward the Siberian coast at speeds exceeding 55 kilometers per year. It had crossed the international date line and was plunging into the Eastern Hemisphere with a velocity that stunned the global scientific community. The situation became so volatile that in early 2019, the World Magnetic Model, the very foundation of modern navigation, from the guidance systems of intercontinental jets to the compasses in every smartphone, had to be updated an entire year ahead of schedule. This was an emergency revision, a rare admission that the planet was moving faster than our ability to map it. The invisible shield that protects our atmosphere from the solar wind was shifting its geometry, and the molten rivers of iron in the outer core were pulsing with a new, frantic energy. For a time, these two phenomena, the speeding rotation and the racing pole, were treated as separate mysteries, isolated anomalies to be debated in the hushed corners of specific journals. But as the data began to coalesce, a haunting realization emerged among the world's geophysicists, oceanographers, and astrophysicists. These were not disconnected events. They were the symptoms of a singular, systemic shift. The Earth is an integrated machine, a complex web of feedback loops where the motion of the core affects the tilt of the axis, and the weight of the oceans influences the speed of the spin. To see both the planet's rotation and its magnetic field deviate simultaneously is to witness a profound change in the Earth's moment of inertia. It is a signal from the deep, a message written in the language of magnetism and time. Something is moving within the Earth, or perhaps something is acting upon it from the outside. The anomalies have moved beyond the realm of mere statistical noise. We are seeing a redistribution of mass on a planetary scale. Is it the melting of the polar ice caps, shifting weight from the poles to the equator and changing the planet's shape? Or is the core itself, the solid iron heart of our world, undergoing a transformation that we lack the sensors to fully perceive? The data points began to form a picture of a planet in transition. We are no longer living on the same Earth that our ancestors mapped. We are riding a sphere that is tightening its spin and shifting its internal weight, reacting to an invisible influence that lingers just beyond the reach of our current theories. The silence of the deep Earth has been replaced by a signal, a rhythmic, accelerating pulse that suggests our sapphire marble is no longer anchored to the constants of the past. As the watchers of the IERS and the BGS continue to monitor their screens, the question has shifted from, "Is something happening?" to a much more unsettling inquiry, "What is the Earth becoming?" The discovery phase of this mystery has left us with a chilling paradox. We have the most precise instruments in history, capable of measuring the heartbeat of an atom and the drift of a continent to the millimeter. Yet, with all our technological might, we find ourselves like sailors on a darkening sea, realizing for the first time that the current has changed, and we are being pulled toward a destination that does not appear on any map. The Earth is speaking, and for the first time in human history, we are realizing how little we understand of its voice. In the cold, analytical world of physics, there are laws that act as the pillars of reality, truths so fundamental they are considered unbreakable. Among these is the conservation of angular momentum. It is the silent hand that governs the spinning of galaxies and the orbiting of electrons alike. For the Earth, this law has always dictated a very specific, downward trajectory. Since the moment of its violent birth from a disk of primordial dust, the planet has been losing its kinetic energy, slowly bleeding its momentum into the vacuum of space. The primary architect of this deceleration is the Moon. Through the invisible tether of gravity, our lunar companion tugs at the Earth's oceans, creating a bulge of water that acts as a physical drag, a tidal break. This friction, occurring relentlessly every second of every day for billions of years, has been lengthening our days by about 2 milliseconds every century. In the age of the dinosaurs, a day lasted only 23 hours. In the distant future, the Earth was destined to become a sluggish, weary world. This was the gospel of geophysics, a slow, predictable descent into a longer night. But the data arriving from our atomic observers has shattered this gospel. The sudden, sharp acceleration of the Earth's spin is more than a mere curiosity. It is a geophysical impossibility under the existing models. To see the Earth speed up is like watching a spinning figure skater suddenly rotate faster without pulling in their arms. It violates the very mechanics of the motion. It suggests that something profound has shifted within the internal architecture of the planet, a redistribution of mass or energy so significant that it has overridden the billion-year influence of the Moon. The scientific community found itself facing a haunting realization. The brake is still on, yet the car is accelerating. To find the source of this violation, scientists had to look where no eye can ever see, the inner sanctum of the world. In early 2023, a landmark study published in Nature Geoscience sent a tremor through the halls of academia. By analyzing the seismic waves from repeating earthquakes that have echoed through the planet's center since the 1960s, researchers discovered a Core-Mantle Paradox that borders on the surreal. The Earth's inner core, a solid, white-hot ball of iron and nickel the size of Pluto, is not a fixed, static heart. It rotates independently, suspended within the liquid outer core like a seed within a fruit. The study revealed that this inner core, which for decades had been rotating slightly faster than the rest of the planet, has recently come to a grinding halt relative to the surface. Even more unsettling is the evidence suggesting it may now be beginning to rotate in the opposite direction. Imagine the sheer, terrifying scale of such an event. Deep beneath the crust, under pressures 3 million times greater than at the surface, a metallic moon weighing trillions of tons has stalled and begun to reverse its course. This is the engine room of our world, the central turbine that generates the planetary dynamo. The disconnect between the spinning crust we inhabit and the reversing heart beneath us creates a friction of a different kind, a magnetic and gravitational tension that may be the hidden hand yanking on the Earth's rotation. This revelation has brought about a profound scientific shock, for the inner core is not merely a buried relic, it is the source of our survival. The movement of the core is what generates the magnetosphere, the invisible, protective cocoon that shields the Earth from the relentless, scouring radiation of the Sun. This magnetic field is the only thing standing between our lush, blue atmosphere and the fate of Mars, a world whose core died eons ago, leaving it a frozen, airless desert stripped bare by the solar wind. The Core-Mantle Paradox suggests that the engine is behaving erratically. If the rotation of the inner core is indeed shifting or reversing, the stability of our magnetic shield is no longer guaranteed. We are witnessing the possible breakdown of the planetary dynamo, a moment where the shiver in our rotation is merely the surface-level symptom of a deep, systemic failure. The stakes of this investigation have transcended the boundaries of theoretical physics and entered the realm of the existential. If the Earth's internal rhythm is failing, the consequences are not measured in milliseconds, but in the survival of the biosphere. A weakening or collapsing magnetic field would allow high-energy particles to penetrate the atmosphere, disrupting global power grids, destroying the ozone layer, and exposing all life to the raw, unshielded fury of the stars. The scientific community is now forced to ask a question that was once unthinkable. Are we living through a paradigm-breaking event, a fundamental shift in the Earth's life cycle that our current theories are simply too young to explain? The violation of planetary inertia is a signal that the Earth is no longer following the rules we wrote for it. It is as if the planet has woken up from a billion-year slumber and decided to change its dance, leaving us to wonder if the stage itself is about to collapse. The mystery is no longer just about the length of a day or the drift of a needle. It is about the stability of the foundation upon which every human achievement has been built. We are passengers on a vessel whose engine is failing and whose course is changing, drifting into a future where the laws of the past no longer apply. To truly comprehend the nature of a planet in flux, one cannot rely on the limited perspective of the surface. To see the invisible, science must ascend. It must cast its eyes downward from the freezing periphery of the atmosphere, using instruments that perceive the world not as a landscape of mountains and cities, but as a complex interplay of invisible forces, magnetic ribbons, gravitational ghosts, and electromagnetic echoes. In the pursuit of the shadow world, the European Space Agency launched the Swarm mission, a trio of sleek, aerodynamic satellites designed to act as a planetary stethoscope. These sentinels orbit within the ionosphere, their sensors tuned to the Earth's magnetic field with a sensitivity that borders on the divine. As they move through the thinning air, they have begun to map a phenomenon that feels less like a scientific data point and more like a wound in the sky, the South Atlantic Anomaly. High above the coast of South America and the Southern Atlantic Ocean, the Earth's protective shield is not merely weakening, it is fraying. The swarm satellites have revealed a vast dent in the magnetosphere, a region where the planetary guard has dropped. Here, the Van Allen radiation belts dip dangerously close to the Earth's surface, allowing high-energy protons from the Sun to flood the space where our satellites roam. It is a zone of technological ghosts, where computers reboot spontaneously, sensors are blinded, and the International Space Station must take extra precautions as it passes through the fray. But the Swarm mission has discovered something even more unsettling. The anomaly is growing. It is stretching westward and, more recently, has begun to split into two distinct lobes. It is a visual representation of a geodynamo in crisis, suggesting that the molten currents 3,000 kilometers below are no longer flowing in the steady, toroidal patterns that have defined the last several millennia. The shield is buckling, and the swarm data suggests that the cause is a deep-seated turbulence that we are only beginning to name. While Swarm listens to the magnetic pulse, another pair of eyes watches the Earth's very weight. These are the twin satellites of the GRACE mission, the Gravity Recovery and Climate Experiment. Nicknamed Tom and Jerry, these two spacecraft chase one another in a perpetual celestial pursuit, separated by a distance of 200 kilometers. By measuring the infinitesimal changes in the distance between them, down to a fraction of a human hair, they can detect the lumpiness of Earth's gravity. For years, GRACE provided the definitive evidence of our changing climate, tracking the trillions of tons of ice melting from the poles and the shifting of the world's great aquifers. But as the mission progressed, a more haunting signal emerged from the noise. The satellites began to register a redistribution of mass that could not be explained by the movement of water alone. Deep within the mantle and the core, the literal viscera of the planet, the heavy, metallic fluids and the scorching rock of the deep interior seem to be migrating. The Earth is fattening at the equator in ways that defy the expected rebound of the crust from the last ice age. It is as if the planet is physically rearranging its internal organs, shifting its center of gravity in a slow, agonizing heave. This movement of mass explains the shiver in the Earth's rotation. When the weight of a spinning object moves, its speed must change to compensate. But the sheer scale of the internal migration detected by GRACE suggests a planetary scale upheaval. We are witnessing the physical manifestation of the Core-Mantle Paradox, a world whose very foundations are in motion, unbalancing the globe and tilting the axis toward a new, unknown equilibrium. But the investigation does not end with magnetism and gravity. There is a third signal, a whisper from the very air itself. Since the 1950s, science has known of the Schumann resonances. This is the heartbeat of the Earth, a set of spectrum peaks in the extremely low-frequency portion of the Earth's electromagnetic field. These resonances are created by the constant discharge of lightning between the surface and the ionosphere, forming a natural, electromagnetic hum that encircles the globe at a fundamental frequency of 7.83 Hz. For decades, the Schumann resonance was a constant, a steady, rhythmic pulse that many believed was intrinsic to the biological health of all living things. But in recent years, global seismograph networks and electromagnetic observatories have begun to record strange, unexplained spikes in this intensity. The heartbeat is no longer steady. It is racing, flickering, and showing bursts of energy that seem to originate not from weather patterns, but from a deeper synchronization with the planet's internal changes. Scientists listening to this hum are finding that the ionosphere, the upper layer of our atmosphere, is reacting to the disturbances in the magnetic field below. As the South Atlantic anomaly grows and the core shifts its rotation, the electromagnetic cavity of the Earth is being reshaped. These spikes in the resonance are the voice of a planet under immense pressure, a sonic manifestation of the tension between the cooling crust and the chaotic core. This deeper investigation has transformed our understanding of the mystery. It is no longer an isolated event in the Arctic or a glitch in an atomic clock. Through the eyes of Swarm, the weight of grace, and the ears of the seismic networks, we see a world in the midst of a profound, holistic transformation. The Earth is being pulled, squeezed, and reshaped from within and without. The invisible forces that once provided the stable backdrop for human civilization are now the very actors in a drama we are only beginning to script. The deeper we probe, the more we realize that the Earth is not a static stage. It is a living, breathing, and now reacting entity. The data points from these disparate missions have coalesced into a singular, haunting realization. We are witnessing the onset of a phase transition. The Earth is shedding its old skin, and the unusual behavior we observe is the friction of a new world struggling to be born. As the satellites continue their silent vigil, we are left to wonder, if the very heartbeat and weight of our world are changing, what remains of the reality we once thought we knew? The deeper one peer into the mechanics of our world, the more one realizes that the Earth does not exist in a vacuum. It is a vital, vibrating organ within the vast anatomy of the cosmos, and when the planet begins to shiver, we must look to the void to see what might be touching it. For decades, we believed the Earth's internal cycles were a closed system, a self-contained clockwork of heat and pressure. But as the anomalies mount, a chilling new possibility has entered the scientific discourse. The Earth is reacting to the interstellar medium itself. Our entire solar system is currently drifting through a region of space known as the local interstellar cloud, or more colloquially, the local fluff. This is a wisp of gas and dust, 10 times denser than the average interstellar vacuum, through which we have been traveling for the last several thousand years. For most of human history, the Sun's heliosphere, a gargantuan bubble of solar wind, has acted as a shield, pushing back against this cosmic fog. However, recent data from the Voyager probes and the Interstellar Boundary Explorer, IBEX, suggest that the pressure at the edge of our solar system is shifting. If the heliosphere is being compressed by an unseen density in the void, that pressure may be translating through the solar wind and into the Earth's magnetosphere. This is not merely a buffet of particles. It is a literal squeezing of the Earth's electromagnetic environment. Like a balloon being pressed by an invisible hand, the Earth's field may be transmitting that external stress down into the liquid outer core. In this view, the racing magnetic poles and the core's stuttering rotation are not just internal malfunctions, but a frantic attempt by the planet to find a new equilibrium against the tides of the galaxy. While we look to the stars for answers, the Earth's physical posture provides another, more visceral clue to its distress. Since the dawn of modern astronomy, scientists have tracked the Chandler wobble, a small, natural deviation in the Earth's axis of rotation. It is a slow, circular dance of the poles, shifting by a few meters over a period of 14 months. It was a predictable, rhythmic nodding of the globe. But in the year 2000, the wobble did something that defied over a century of observation. It stopped. The axis took a sharp, 90-degree turn, abandoning its historical path and beginning a new, erratic drift toward the meridian of Greenwich. For years, the scientific community was silent, paralyzed by a data point that seemed to suggest the Earth had glitched. When the movement finally resumed, it was different, faster, more unpredictable. The planet was no longer wobbling. It was limping. This righting of the axis suggests a subterranean shift of such colossal proportions that it staggers the imagination. It is as if the very skeleton of the world has cracked and reset itself. If the core has indeed slowed or reversed, the resulting torque on the mantle would be enough to physically tilt the planet. We are witnessing the Earth attempting to balance itself on a new center of gravity, a process that moves mountains and reshapes the seafloor, yet happens so deep beneath us that we perceive it only as a drift in a coordinate system. But it is the clock that provides the most harrowing evidence of this escalation. In 2020, The scientific world watched in stunned silence as the Earth recorded the 28 shortest days in the history of human measurement. This was not a minor deviation, it was a fundamental acceleration. In the language of physics, when a spinning object speeds up without an external force, it must be changing its shape. A figure skater spins faster by pulling her arms inward, concentrating her mass toward her center. But the Earth has no arms to pull. To explain a milliseconds gain in a single day, the Earth must be tightening. It must be becoming more compact, more spherical. Some researchers point to the melting of the cryosphere, suggesting that as ice leaves the poles and water moves toward the equator, the planet's waistline is changing. Yet, the math doesn't fully reconcile. The acceleration is too aggressive, too sudden for the slow grind of climate change alone. It suggests a shrinkage of the internal layers, a cooling or a densification of the mantle that is pulling the crust inward, even if only by a few centimeters. This is the terrifying core of the mystery. The Earth is changing its shape, its spin, and its tilt simultaneously. It is as if the planet is preparing for a transition into a different state of being. We are watching the escalation of a planetary crisis where the variables are no longer behaving linearly. The shiver has become a heave. As we look at the data from 2020 and beyond, we realize we are no longer in a period of stability. We are in a period of geophysical departure. The laws of planetary inertia, which we once thought were as stagnant as the stone beneath our feet, are proving to be fluid. The Earth is reacting to the void, to its core, and to its own changing weight in a symphony of anomalies that point to a single, inescapable conclusion. The Earth is no longer the world we were born into. It is a ship that has caught a new wind, a dark, interstellar wind, and is beginning to accelerate into a future for which we have no charts. The mystery has deepened from a question of how to a question of where. Where is this acceleration taking us? If the days continue to shorten and the poles continue to race, at what point does the biological clock of humanity lose its synchronization with the world? We are living through the greatest escalation in geological history, a silent revolution of the sphere, occurring in the dark, cold spaces between the atoms and the stars. To gaze into the abyss of the Earth's accelerating spin and its wandering poles is to confront a silence that science is desperate to fill. When the classical models of geophysics fracture, we are forced to look toward the periphery of our understanding, into the architecture of the unseen. We must entertain theories that only a decade ago would have been relegated to the realm of science fiction, but which now find their way into the peer-reviewed corridors of the world's most prestigious laboratories. If the Earth is behaving like a body possessed, we must identify the spirit pulling its strings. One of the most haunting possibilities lies not within the Earth, but in the very fabric of the space through which it sails. We call it the dark matter tether. For nearly a century, astronomers have known that the visible universe is merely a thin translucent film stretched over a vast, invisible scaffolding of dark matter. This substance, which does not emit light or heat but possesses an immense gravitational thumbprint, is not evenly distributed. Some astrophysicists propose that our solar system may be passing through a clump or a stream of this invisible matter. According to the math of Einstein's general relativity, mass warps spacetime. If the Earth were to encounter a dense filament of dark matter, an invisible hair of the cosmos, the gravitational interaction would not be felt on the surface, but in the densest part of our world, the core. This invisible anchor could be creating a subtle drag or a localized gravitational torque, pulling on the Earth's iron heart while the crust continues to spin. Such a tether would explain the sudden, localized acceleration of the rotation and the erratic drift of the magnetic poles, as the planet struggles to maintain its orientation against a ghost it cannot see. We are, perhaps, experiencing the first tangible friction of the dark universe. However, if the cause is internal, we must re-examine the very nature of what lies at the center of our world. For generations, we have taught that the core is a simple ball of iron and nickel, cooling slowly over eons. But the georeactor hypothesis offers a more volatile alternative. This theory suggests that deep within the inner core, heavy radioactive elements like uranium and thorium have concentrated due to their sheer density, forming a natural nuclear fission reactor. If such a georeactor exists, it would not be a static engine. Like any nuclear pile, it would be subject to cycles of activity, surges of heat and radiation that could trigger massive plumes of buoyancy in the liquid outer core. A new phase of activity in this primordial furnace would explain the sudden heating of the mantle and the redistribution of mass detected by our satellites. It would be as if the Earth's pilot light has flared into a blowtorch, churning the molten seas of the interior and causing the crust to shudder and speed up in response to the thermal upheaval. The shiver we feel is the vibration of a planet-sized engine shifting into a higher gear. Yet, there is a more ominous shadow looming over the data: the fluid dynamo failure. The Earth's magnetic field is a delicate miracle generated by the organized flow of liquid iron in the outer core. But geologic history tells us that this field is not permanent. Every few 100,000 years, the field weakens to the point of collapse before flipping, a geomagnetic reversal where north becomes south and south becomes north. We are currently long overdue for such an event. The racing of the magnetic North Pole towards Siberia and the deepening of the South Atlantic anomaly are the classic hallmarks of a dying dynamo. We may be witnessing the beginning of a multi-century period of magnetic chaos. During a reversal, the Earth's protective shield does not simply swap positions. It disintegrates into a complex web of weak, competing poles. For a time, the Earth would be left virtually unshielded, its atmosphere exposed to the raw, ionizing radiation of the solar wind. The unusual behavior of our world today may be the final, flickering gasps of the magnetic era that birthed human civilization, the herald of a world where the very sky becomes a source of peril. Finally, we must consider the most radical architectural shift of all, the Great Crustal Displacement. This theory, once championed by Charles Hapgood and even explored with interest by Albert Einstein, suggests that the Earth's lithosphere, the thin, brittle shell we inhabit, is not as securely fastened to the mantle as we believe. If the redistribution of mass at the poles and the equator reaches a critical tipping point, the entire crust could, in theory, slide over the lubricated layer of the asthenosphere. In this scenario, the Earth is not merely spinning faster, it is attempting to find a new physical equilibrium. The glitch in the Chandler wobble and the erratic path of the axis suggest a planet whose skin is becoming untethered from its bones. A crustal displacement would be an event of biblical proportions, moving entire continents into new latitudes in a geological heartbeat. While most mainstream geologists view this as a slow, million-year process, the current anomalies suggest that the lubrication between the layers, perhaps heated by the georeactor or the dark matter tether, has reached a state of unprecedented fluidity. Each of these theories paints a picture of a reality far more fragile than we dare to admit. Whether we are being dragged by the invisible threads of the dark universe, fueled by a subterranean nuclear fire, or witnessing the collapse of our magnetic sanctuary, one truth remains: the Earth is no longer a stable platform. It is a dynamic, evolving architecture, reacting to forces that dwarf the scale of human existence. We are forced to reflect on the nature of our certainty. We built our cities on the assumption of a static north. We timed our lives by the assumption of a constant day. But if the architecture of the unseen is shifting, then the foundation of our world is not stone, but a shifting sea of iron and mystery. As we move closer to the truth, we find that each answer only deepens the poetic terror of our situation. We are not just living on a planet, we are riding a transformation. Faced with a planet that has begun to whisper in a tongue we do not yet speak, humanity has turned to its most sophisticated sensory organs. To find the why behind Earth's accelerating spin and its wandering soul, we have constructed cathedrals of glass, steel, and silicon. These are not merely machines. They are the modern equivalents of the ancient oracles, designed to listen to the vibrations of the subatomic and the echoes of the infinite. If the Earth is indeed undergoing a phase transition, we must use the very fabric of reality to measure the depth of the change. The search begins deep beneath the surface, far from the interference of cosmic rays and human noise. In the hollowed-out caverns of a former gold mine in South Dakota, the deep underground neutrino experiment or dune, is taking shape. While its primary mission is to study the ghost particle of the universe, it has become an accidental X-ray machine for the planet itself. Neutrinos are nearly massless particles that stream through solid rock as if it were empty air. By firing a beam of these particles from Fermilab in Illinois through 1,300 kilometers of the Earth's crust and mantle to the detectors at Dune, scientists are beginning to perform a planetary CAT scan. As these neutrinos pass through the Earth's interior, they are subtly altered by the density and composition of the material they encounter. By monitoring the flavor of these particles as they arrive, physicists can map the deep density of the mantle and the state of the outer core with unprecedented resolution. They are looking for hot spots or unexpected voids, evidence of the mass redistribution that the gray satellites have only hinted at from above. Dune provides the data needed to see if the core is truly reversing or if a subterranean nuclear fire is stoking the planet's internal engine. It is a race to visualize the invisible before the physical consequences of the shift become irreversible. While Dune peers into the depths, the James Webb Space Telescope, the most powerful eye ever turned toward the heavens, is looking outward to settle a critical debate. Is this a planetary sickness or a systemic one? If the Earth's shiver is caused by an external force, such as a clump of dark matter or the pressure of the local interstellar cloud, we should see its fingerprints elsewhere. The JWST is currently being used to monitor the atmospheric dynamics and orbital stabilities of our sibling worlds, Jupiter, Saturn, and even the icy sentinels of Uranus and Neptune. If the Great Red Spot is behaving erratically, or if the rings of Saturn are showing gravitational ripples that don't align with known orbital mechanics, it would prove that the Earth is not an isolated casualty. It would suggest that the entire solar system is moving through a thickening of space, a region of the galaxy where the constants of movement are being rewritten. The telescope is searching for a cosmic commonality, a sign that the solar system's grand clockwork is feeling the same drag that has accelerated our own world. Closer to home, we continue a conversation that began over 50 years ago during the Apollo missions. On the surface of the moon sit small, suitcase-sized arrays of mirrors, the laser-ranging retroreflectors. By firing high-powered laser pulses from Earth and timing their return to the picosecond, scientists can measure the distance to the moon with the precision of a few millimeters. This experiment has become the ultimate test of the gravitational constant. If the Earth's rotation is speeding up because of a fundamental change in how mass interacts with spacetime, we should see a hiccup in the moon's orbit. If the gap between our world and its companion is widening or narrowing in a way that contradicts the laws of general relativity, it would confirm that the cosmic anchor is failing. This lunar laser ranging is the yardstick by which we measure our stability. It tells us if the rules of the game are still the same, or if the board itself has begun to warp. But perhaps the most profound investigation is taking place at the Large Hadron Collider at CERN and within the ultra-precise laboratories of atomic physicists. They are hunting for a variation in the fine structure constant, the number that governs the strength of the electromagnetic interaction. It is one of the fundamental constants of nature, a number that dictates how atoms hold together and how light moves. There is a radical, growing theory that as our solar system travels through different sectors of the universe, the constants of physics may not be constant at all. If we have entered a region where the strength of electromagnetism is slightly different, it would explain everything. It would explain why the Earth's atomic clocks are out of sync with its rotation, why the core's magnetic dynamo is failing, and why the very atoms of our world seem to be vibrating to a different tune. It would mean that the unusual things happening to Earth are not a violation of physics, but the result of physics changing around us. This is the race against time. Each instrument, the neutrino detector, the space telescope, the lunar laser, and the particle collider, is a different lens through which we view a changing reality. We are trying to find the why before the what becomes too much to bear. The ongoing testing represents the pinnacle of human curiosity and our deepest survival instinct. We are measuring the shiver of the world to see if we can still call it home. As the data streams in from these disparate sources, the mystery only deepens. Each measurement confirms that the old world is receding and a new, more volatile reality is taking its place. We are looking for a singular answer, but we may find that the answer is as vast and complex as the universe itself. We are no longer just observers. We are the measured, living on a sphere that is being tested by forces we are only beginning to name. The scientific tools of today are the only hope we have of understanding why the Earth has decided, after eons of silence, to move in a way it never has before. The architecture of human civilization is not built upon stone or steel, but upon a more invisible and precarious foundation, the assumption of constancy. We have lived our brief, flickering lives under the absolute conviction that the parameters of the world are fixed. We wake with the certainty that the sun will crest the horizon at a mathematically precise moment. We navigate our oceans and our skies trusting that north is an immutable destination. We build our cities and our lives on the silent promise that gravity is a stable, unyielding law. This predictability is the heartbeat of our species. It is what allowed us to transition from nomadic wanderers to the architects of the digital age. We have outsourced our survival to the reliability of the Earth's rotation and the steady rhythm of its magnetic shield. Yet, as we have seen, the constants are beginning to fray. The realization that the Earth is speeding up, that its core is stuttering and its poles are in flight, shatters the illusion of a static reality. It forces us to confront a humbling truth. We are not the masters of a clockwork machine, but inhabitants of a dynamic, shifting entity that owes us no permanence. The fragility of our world is not found in its susceptibility to external impact, but in the internal volatility of its own existence. When the fundamental metrics of the planet deviate, we realize how thin the ice of our certainty truly is. In this light, the Earth reveals itself as something far more profound than a dead rock suspended in a vacuum. We are forced to meditate on the image of the world as a complex, breathing organism, a Gaia that is intimately and perhaps painfully reactive to the cosmos. The anomalies we witness, the shivers in time and the limps in our axial tilt, are the physiological responses of a planet navigating a changing galactic environment. If the Earth is passing through a thickening of interstellar space or reacting to a subterranean nuclear flare, it is doing so as a living system seeking a new equilibrium. We are witnessing a planetary metabolism, a grand redistribution of mass and energy that suggests the Earth is not merely a stage for our history, but a protagonist in its own right, one that is currently undergoing a deep, metamorphic transition. This shift invites a profound, existential humility. For all our technological reach, for all our ability to split the atom and peer into the birth of the first stars, we remain ephemeral passengers on a 4.5 billion-year-old vessel. We are a recent addition to a journey that began long before the first oxygen was breathed, and which will continue long after our languages are forgotten. To observe the Earth's unusual behavior is to realize that we are not the pilots of this ship, but its witnesses. We are like mayflies observing the turning of the seasons, mistaking the momentary calm of the last few millennia for the permanent state of the universe. The mystery of the Earth's change is a stern reminder that the universe owes us no predictability. It does not exist to facilitate our schedules or to validate our maps. The unusual things happening to our world are only unusual to us because our perspective is so tragically brief. In the grand timeline of the cosmos, stability is the anomaly, change is the only true constant. The accelerating spin, the drifting north, and the stuttering core are the Earth's way of reclaiming its narrative, reminding us that we live by the grace of geophysical stability, not by right. As we stand on the edge of this new epoch, we are left with a sense of quiet, profound awe. To look at the horizon and realize the sun has risen a fraction of a second earlier than the old math predicted is not just a scientific observation, it is a spiritual one. It is the realization that the ground beneath our feet is moving in ways we cannot control and barely understand. We are entering a future where the old anchors have been lifted, and the ship has begun to drift into a darker, more volatile sea. The story of the Earth is changing. Its rhythm is new, its posture is shifting, and its heart is restless. We are the generation destined to watch the constants dissolve, to feel the first tremors of a world that is becoming something else. And perhaps, in that uncertainty, there is a strange kind of beauty. For it is only when the clockwork breaks that we truly appreciate the magnificence of the machine. We end our journey not with answers, but with a gaze turned toward the shifting sky, acknowledging that we are part of a mystery so vast that it can only be met with silence. The world is moving, all we can do is watch.